Hello everyone, welcome back and thank you for checking out this video. Today we're going to be talking about integer exponents. So let's start off with this problem, 5 to the power of 3. To simplify this, our exponent is 3, so we're going to be multiplying 5 by itself 3 times. So 5 times 5 times 5, which is also equal to 125. Let's look at the basic form that applies to any exponential equation or term. A to the power of h, where a is the base and h is the exponent. Another example using this basic form is negative 3 to the power of 4. But this one is a little bit more challenging since we have a negative sign. If negative 3 were to be in parentheses, then we wouldn't have to separate out the negative sign when we're actually multiplying it out. But since negative 3 isn't in the parentheses, we have to take out the negative sign and multiply 3 by itself 4 times. This part of the equation equals 81, and if we multiply it by negative, we get negative 81. Okay, next up we have 0 and negative exponents. Let's look at 0 first. Our basic form for this one will be a to the power of 0 is equal to 1. Means that if you have any term to the power of 0, it equals 1. Let's look at an example using the same form. Negative 1/2 to the power of 0 is equal to 1. Self-explanatory, anything to the power of 0 is equal to 1. But take note, if you have 0 to the power of 0, your answer will be undefined. It will come out as an error in your calculator, and the answer will be indeterminate. The only exception to this basic form is that your base a cannot be equal to 0 because it will be undefined. Moving on, we have negative exponents. Our basic form for this will be a to the power of negative h is equal to 1 divided by a to the power of h. I like to think of it as you're just moving a to the power of h to the denominator, and that will take out the minus sign. But we have a few restrictions to this. This is only true while a is not equal to 0 and h in the denominator is a positive integer. It's crucial that both of these restrictions are met, otherwise we might end up with 0 to the power of 0, which is undefined, and we don't want that in the denominator of this equation. So let's look at an example. 2 to the power of negative 3. We can move 2 to the power of 3 to the denominator and put 1 over it. So we get 1 over 8, since 2 to the power of 3 is 8. Okay, now that we have those examples out of the way, we can look at laws of exponents. Now, these laws are going to be crucial to solving every single exponential equation that you come across. There are a total of 7, so we're going to go through them step by step. The first one we have a to the power of m times a to the power of n is equal to a to the power of m plus n. So basically you're just adding up the exponents as long as the base a is the same. Here's an example, 4 to the power of 5 times 4 to the power of 2. We get 4 to the power of 7 since we have 4 to the power of 5 plus 2. And then if you put that in your calculator or solve it, you get the answer 16,384. The second law, a to the power of m divided by a to the power of n. This one is the opposite of the first one. You're just subtracting your exponents now. So you get a to the power of m minus n. For example, if you have 4 to the power of 5 divided by 4 to the power of 2, you get 4 to the power of 3, since you have 4 to the power of 5 minus 2. And if you solve this, you end up with 64. Your third law is going to be a to the power of m to the power of n, and this is multiplication of the exponents. For example, if you have 3 to the power of 2 to the power of 4, you get 3 to the power of 8. Imagine it as if you're doing 3 to the power of 2 times itself 4 times. You're going to get 3 to the power of 8. And if you solve that, you get 6,561. Your fourth law is going to be ab to the power of n, which is equal to a to the power of n, b to the power of n. For example, if you have 5 times 2, I just did it to the power of 1 to make it easier to understand, you will get 5 to the power of 2 times 2 to the power of 2. I like to think of this law as distribution. So you're distributing the power or the exponent to each base. And then if you solve this, you get 100. Your fifth law is going to be a divided by b to the power of n is equal to a to the power of n divided by b to the power of n. Here's an example. 4 to the power of 1 divided by 2 to the power of 1 to the power of 3. You will distribute the 3 as in the last example, except you're going to be dividing this time. So you get 4 to the power of 3 divided by 2 to the power of 3, and this will equal 8. Your sixth law is going to be a divided by b to the power of negative n is equal to b divided by a to the power of n. As an example, we have 3 divided by 4, to the power of negative 2. You can transform this into 4 divided by 3 to the power of 2, getting rid of that minus sign and instead flipping the numerator and denominator. If you solve this, you get 16 divided by 9. And finally, your seventh law is a to the power of negative n divided by b to the power of negative m is equal to b to the power of m divided by a to the power of n. Again, just remember that if you have any sort of negative exponent, you have to switch the numerator and denominator. As an example, 2 to the power of negative 2 divided by 3 to the power of negative 1 is equal to 3 to the power of 1 divided by 2 to the power of 2. If you simplify this, you get 3 divided by 4. Okay, so that was an overview of the laws of exponents, and this sums up the session on integer exponents. Hopefully you learned a little bit more about exponents from this video, and please comment down below which video topic or subject you would want to go over in the next video. Also, like and subscribe if you want to see more videos like this, and please share this video with anybody who you think it might benefit. Thank you.